Good evening to everyone present. Can you just confirm in the chat if we're audible to you? So the thing with StreamYard is that there's a 10-second delay. So at the beginning of the stream, you have to just sit there for 10 seconds, waiting for people to say if it's audible. But
Okay.
if it's audible, just drop a yes in the comments, please. Okay, perfect. So, good evening, everyone. I am Utkarsh, and I'll be your host for today. Along me, we have two distinguished professionals from the data science industry, Suyash and Anurag. So Suyash Harlalka is the lead AI engineer at Insane.ai, which is a fitness metaverse startup that gamifies the daily experience of building your health. And he has also had a stint as a data scientist at Shadowfax. While Anurag Bajpai is the lead data scientist at Shadowfax, which is also the title sponsor for our data science challenge, Cascade Cup 22, of which many of you might be a part of. So, without further ado, we'll let these distinguished gentlemen take over. So, yes, Anurag, you have the floor.
Hello, everyone. Uh, it's actually a great opportunity for me to tell you guys a little bit about what Shadowfax is and how exactly is the data science problem tackled across industry and at Shadowfax in particular. So let's first start with the name of Shadowfax. Um, to give you a very brief description of what Shadowfax is. Shadowfax is a logistics company. Our closest competitor in the market is Delivery, which you guys must have heard of. So the name Shadowfax comes from a mythical character of Lord of the Rings, where the horse is known for his speed, reliability, and and his swift response in general in any sorts of situations. And that's the kind of logistics services we want to provide to our clients. And hence, we named ourselves Shadowfax to start with. Moving forward, the core concept of Shadowfax is to enable commerce by empowering everyone and everywhere. And this could be seen in the fact that we have been able to provide employment to a whole bunch of people who were earlier unemployed just by enabling them to be able to be our delivery partners with minimum backlog. Along with that, our core values centered around customer centricity, which is our clients, innovation, empathy, and integrity. I'll be showing you different building blocks of how we incorporate innovations as well as integrity in our system. And the whole mission of the company is essentially to build the fastest and the most reliable logistics network, which would help small businesses along with the bigger ones to scale and empower their commerce at scale. Currently, Shadowfax has is about to turn 7 years old, and during the span of these 7 years, we are a community of about 55,000 plus people. Amongst that, you could see that we have grown from a really small team to to having over 1,500 on-roll employees, along with having 3,600 more off-roll employees. Um, and if we look at our delivery partner base, then we have more than 50,000 active monthly users at the current time point. So at the very core, if you ask us who we are, what is Shadowfax, then the simple answer that comes out is we are a startup. Although we have been in existence for 7 years, although we have raised a considerable amount of money over these 7 years, we recently raised our Series G in December 2019, which was led by Walmart. Irrespective of all these things, we still have a very core startup mentality, which allows us to put aside all our inhibitions and work towards technological innovation it it creates a conducive environment for everyone to try and test out different things. We do not, I would say, cage people to one particular responsibility and are open for them to switch their roles. We actually encourage people to turn on different hats, and we make sure that you are actively recognized for the amount of work you put in. We are always open to new ideas, and you always have the opportunity to try and test your ideas and put them on the field if they work without much lag. So that's the whole concept of uh, concept of startup that we always try to take ahead with us. And maybe that's the reason that we are growing at kind of a similar pace, even right now, 7 years down the line, as we were, let's say, growing 3 years back. So that's what we are, and that's essentially what the culture at Shadowfax is. It empowers you as an individual to go and self-explore and work on the things you like, which obviously lie within the domain of the company. And it gives you enough freedom to be your own mentor at every point during your stay at this company. Uh, if we talk about my journey at Shadowfax, so I did my MS from Washington University, and then I came back in January 2020. I started working with Shadowfax in January 2020, and during my stay of close to 18 months at Shadowfax, I worked on a whole range of different problem statements. These ranged from working on probabilistic modeling to incorporating core deep learning concepts into natural language processing and getting it out as a final product for the company. But the whole crux of the matter does not lie in the whole bunch of projects that have been undertaken. It lies into something that is more fundamental to the projects that are undertaken at this company at Shadowfax, which revolve around three layers. The first layer is about the concepts, the, the concepts that you apply in or that you bring along to solve any problem, ranging from probabilistic modeling to handling problem statements belonging to computer vision to making use of those fundamental concepts and being able to apply them into problems of natural language processing. So there's absolutely no restrictions to the kind of problem statement you can and you will be working on. Along with this, we also work on the optimization front, which takes into account a lot of classical computer science based algorithms like optimizations uh, and basically trying to cut down the on the both the time and cost for this logistics. Uh, you would be dealing with both kinds of data over here, ranging from structured data to unstructured data. By structured data, I mean the regular tabular data that people come across, and by unstructured data, I mean the data pertaining to images, texts, audio signals, or any sort of signal out there. The whole, irrespective of where you come from, the whole meat of the matter is that you're trying to optimize logistics and its operations. You're trying to reduce the ground time that is mostly delayed by inefficient human work so that you can help people do logistics and facilitate the movement of goods and products at scale without much delay. So that's basically what each and every project at Shadowfax aims to do. And the fundamental goals of every project can be branched into three categories. Uh, your projects could be used for operational deployment, which means they could be directly used in helping the business grow. They could also be used to improve the internal workings and internal dynamics of the company. Because we're working with data science in the data science domain, and there's data for both the functioning of the business as well as what's going on inside the business. You can use those data science methods and algorithms to very accurately identify the inefficacies within the system and help them improve it. And we strongly believe that that is one of the very important things that needs to be done in the business as the business grows, because a lot of redundancies try to keep like tend to creep in, and a lot of inaccuracies lead to not so efficient functioning of the business in general. So this is one of the very important domains that we channel our data science power towards. Apart from that, you also have data science projects where you use those concepts to try and get rid of the noise from your data so that that data could be again used downstream in a bigger project. I would be showing you an example of something similar to this, but essentially we are not always towards cleaning data by doing manual work. We are more centered towards cleaning data using some witty method so that we can get rid of, let's say, 80% of junk data using minimal efforts, rather than going for something that is for something more manual that would take a lot more time and would barely give us any advantage in terms of accuracies. So those are the general three goals of any project that you look into. Okay, so now getting into projects, what are the exact projects that what are some of the projects that we have undertaken at Shadowfax, and what has their impact been? So to start off with, we need to understand that Shadowfax is a logistics company, and at the very core of logistics, it's to know where a particular address is. We are the last, in general, we are the last mile delivery providers. So it's very important for us to know where exactly your address is. Today, if you say that, okay, you live in Hostel 9 IIT Guwahati, then we should know where exactly is Hostel 9 IIT Guwahati. Is it close to Hostel 11, or is it close to Hostel 2? And given the Indian demographic and the addressing system, there is no clear way to understand and know where a particular address is. Now, if you think about it, then even Google Map does a similar thing. You go on Google Maps, you type your address, and you get a particular pinpoint. Okay, here is that address. So what exactly is going on in Google Maps? What that Google Maps is doing is it's taking your address and it's trying to give you the geographical coordinates for that particular address. And Google Maps is fine. Google Maps works great in the United States. It is kind of good in India, but for the kind of hyperlocal deliveries that Shadowfax does, that we do, it isn't that accurate. And I'm going to show you how what is the difference between our algorithm and theirs. But tomorrow, if you go and write something like Gully number 14, सामने वाले मस्जिद के सामने घर number 15 on Google Maps, most certainly you are going to land up nowhere. But for our delivery partners, we come across these kinds of addresses on a very daily basis. So, and we just cannot say that we don't know where the address is, because it's not going to help us in any way. So what we have done is we have built an internal geocoding engine, which takes in any address string and it tries to give you the exact coordinates of that particular place. So the problem statement that was in hand was, given an address string, estimate the geographical coordinates as closely and as precisely as possible. Um, so here is an example of what the geocoding engine does. You can see that we have sent an address, which is BA01 Greenwich Waters, Owners Court Layout, Kasavanalli. So this is an address in Bangalore, and we are trying to get the exact coordinate of this. And now if you put this into our geocoding engine, you get a response, and that response is a geographical coordinate where the first index is the latitude and the second index is the longitude. Now, if you actually see that with what's going on in Google Maps, and if you actually go and visit this coordinate, you will land up at this particular location. And this is something that is completely built in-house. So every time you ask Google maps as a company to give you a coordinate of a particular location is going to charge you some money. Now this has cut down on that cost altogether, and that transactional cost is pretty high given the number of addresses and the number of shipments we deliver every day at today's scale. So, and now moving forward, when we actually try to see, okay, how well is our algorithm doing well with respect to what Google is doing? Because honestly, Google is like this holy grail for everything, right? So, and so if we were trying to see how good it's doing with these local addresses, what we found was pretty surprising. What we actually found was our algorithm, our in-house algorithm was actually a lot better than Google for these local addresses. You could see that, okay, Google Maps gives you close to 59% of addresses within the 200-meter radius of where the actual address is, whereas our internal geocoder, it gave about 600% when it came to the radius of 200 meters. Now, when we scaled it to like 500 meters, our algorithm was a lot better. We were able to get 81% of addresses within that 500-meter uh, radius. And remember that these addresses are not structured. These addresses could literally be anything. These could have locality first, building name later. This could have locality first, uh, the apartment or the house number or something else later. This could have a pin code missing. This could have a locality missing. It could be anything. There's no guarantee that the input you're getting is the actual address, as well as there's no guarantee that it's properly structured. So there is no structure. So when we were looking at this, and then when we were actually contemplating about the culture that we were speaking previously, we could clearly see that being limited by the scope of Google is not good, because at the end of the day, there is someone like you and me working at Google. It's not magic happening. It's a person. And the reason we were able to get such good results was because, okay, one part of it was the brain behind it, but then the major part of it was also the culture behind it, where they kind of pushed you to go and explore it and 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 try to do as good as you can in this particular domain rather than just relying blindly on Google and saying, okay, they are the best and there's nothing better we can ever get. So this was one of the projects that we were talking about that had a huge impact in the overall operation of the company. Uh, so one of the major implications of this particular project was helping us cluster shipments. So you could imagine that, okay, every day as a company, we have to deliver or pick up shipments from so many different places. And it would be so inefficient if we start sending people to a particular location at random. Because let's say if there are two places close by, then you would want to get them picked up or delivered by a single delivery personnel. And that wouldn't happen if you cannot accurately predict where their addresses are. So the exact problem statement was for this particular problem was given a list of addresses, group them into clusters such that similar addresses which are close by geographically, can be addressed at once. This addressal could happen at any scale. This addressal could happen at one delivery boy scale, or this addressal can happen at one delivery truck scale. Let's say you want to group addresses belonging to one apartment together, you can do that. Or let's say you want to group addresses belonging to one locality together, you could do that too. That just depends. That would just be depending, like that would only influence the way you are defining your clusters to be. But the major goal would be to have such control and be able to get these accurate clusters. And so what the input, going in a completely technical domain, what the input to this kind of problem statement would be is you'll literally just have a list of addresses and nothing else. So now what do? You pass these list of addresses through our geocoding engine. Once you do that, you get the geographical coordinates and you plot them on the map. Now, once you have plotted them on the map, you have a kind of a sense as to what's going on over here. Now you have some basis in which you can cluster these. Once you apply your clustering algorithm based on what scale you want the clusters to, you get clusters. In this second figure, dots belonging to same clusters are of the same color. Mind it that this brown and this brown are actually different shades of brown. And similarly for these two, uh, I would say shades of orange or peach or whatever you guys want to call it. It's just because of the dynamic range of the screen, we are able to we are seeing them so similarly. So yeah, now okay, you have the coordinates, you have the clusters. Now what goes on in the operations? How do we know that this is actually correct? How do we know that there is things are going correctly over here? So what you do is you ask people on the ground to manually curate different segments. You divide the city into different polygons and you ask them to manually curate it. So if you look at this figure, you can see that one color belongs to one polygon. And now what you do is, now if you closely see what's going on over here, you could see that, okay, in this polygon, there are dots belonging to one particular shade. In this polygon, there are dots belonging to one particular shade. What essentially this tells you is the clusters that were made or the regions that were marked manually to be close by are actually have been clustered to be close by the algorithm. Now this gives you confidence. This opens up the opportunity to let your system do the clustering, which was previously being done by someone sitting at your hub at some center automatically. This reduces the time load dramatically. It also opens up the human workforce for something that is more required rather than just clustering the addresses over there. What this has essentially helped us do is at this point of time, we automatically cluster close to 10,000 shipments every day. And it's also extremely easy to scale. We have been able to scale it from one city to three at this current moment, and we are actually looking to scale it to to many more in the future. So that's the whole power of technology, and that's the kind of technological innovation we are we are striving forward for. One other project which we undertook, which was extremely novel at that point of view, was to get the was essentially to get the intent out of the phone call between the rider and the customer. So let's say our delivery partner has to deliver something to a customer, and he calls up the customer, and the customer is like, okay, please don't come today. I'm not at home. Please come tomorrow. But the delivery rider marks it as cancelled and not to be as delivered tomorrow or come back later. So what happens then? Because it has been marked cancelled, it goes back to our client. Let's say our client is Flipkart or Nykaa or Amazon. It goes back to them. And then if our client rechecks with their customer as to did they actually cancel it, they get a negative answer. This leaves a very bad impact for us. This leads to an extreme bad reputation with the client. So in order to do that, what we thought of doing was we thought of placing in a system which would take in an audio recording, basically a conversation going on between the delivery personnel and the customer, and then we would try to churn out the intent out of it. So the input would actually be uh, it would actually just be an audio data. Let me just share with you what an example of audio looks like. Uh,
हेलो
yeah.
हाँ मैम आपका 380 का पार्सल है मैम चाहिए
क्या चीज
380 का पार्सल है आपका
180 का कोई पार्सल नहीं होगा 379 का होगा
वही मैम 380 ना हुआ
कल लेके आइएगा
मैम ऐसे कल तो बोले थे मैम बोले थे आप आ गया ऐसे कीजिएगा मैम इसे कैंसिल कर दीजिए सब जैसा
इस नंबर से तो नहीं आता फ्लिपकार्ट का
इसी नंबर से आया मैम
तो इस नंबर से तो नहीं आता है आपको किस नंबर से हमको कॉल करते हैं हमको दूसरा नंबर से आता है आप फर्जी वाला नहीं ना कर रहे हैं
फर्जी वाला हम काला करेंगे मैम, आपको
तो
पार्सल
फर्जी
देना
वाला
है
करिएगा तो हम कंप्लेन कर देंगे, इस नंबर से नहीं आता है मेरा फ्लिपकार्ट का अथी पार्सल।
तो कुछ कौन नंबर से आता है?
चलिए कोई नंबर से आता है, आपको कंप्लेन इस नंबर का कर देंगे हम, समझे? हमको बेवकूफ मत समझिए।
ठीक है कम।
Yeah, so hopefully all of you heard the conversation that was going on between the delivery rider and the customer. And over there, the customer was like, okay, I'm not completely sure if you're genuine or not. And the delivery rider is like, yeah, okay, fine. I'm telling you I'm genuine. But then the conversation just didn't go anywhere. And at the end of it, the rider marked it as a cancelled shipment, whereas there was no talk of cancellation going on. The customer didn't actually say the rider to cancel the order, but the rider marked it to be cancelled. So now what would happen is like if we send the shipment back to Flipkart, then Flipkart will come back to us and they will say that, hey, dude, our customer did not cancel this order. Why have you canceled it? This is not how this is supposed to work. And then we'll have to do it all over again. And then this is going to keep on. And then this is just going to be more and more costly for us. And so what we did was we put in an engine which would take this audio conversation and would tell us what is being talked about. And you can see that the predicted final status is not cancelled. So our algorithm says that the conversation was not cancelled, but the writer still marked it to be cancelled. So under such situations, we can, rather than sending it back to the Flipkart, we can ask our delivery rider to just reattempt it. This would reduce so much cost for us. And indeed, it did reduce a lot of cost for us. Um, so what it has helped us do is it has helped us cancel the actually cancelled orders. It has helped us reduce the turnaround time from like it has helped us cut that time by 70%. So like earlier, we would this entire process would take close to 24 hours per shipment. Now this takes close to like 3 to 4 hours. Now what that has essentially done is we can go through a lot more of return shipments and reduce on the operational time front than anything else. And it has also helped us improve our relationship with our clients, which is of extreme importance for any logistics business. Um, Apart from this, so firstly, we dealt with a string data, then we dealt with audio signal. Now I'm going to show you some project where we were dealing with image data, which pertain to the computer vision department of artificial intelligence. In this, the problem statement was given a selfie, figure out if the rider has put a mask on or not, given a, whether he has a sanitizer with himself or not, or whether he's wearing a Shadowfax t-shirt or not. Now, this entire project was started right at the beginning of the very first lockdown, and we were able to roll this entire thing out within like 10 days. And the whole and 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 when we started off with this project, we didn't even know how possible it would be to do it. So the whole reason we were able to take this project up was because of the freedom and independence that people and administration at Shadowfax allows you to have. And you can see in these couple of like in these examples that we were able to accurately detect where the sanitizer is, and we were able to accurately say that yes, the person is wearing a Shadowfax t-shirt and has a mask on. And we actually were rewarded also by by the Aegis Graham Bell Award Committee for this particular project, because this is one place where we really put the use of technology for both the benefits of our customers as well as for the safety of our riders. And at peak COVID time, we were able to go through close to 40,000 selfies every day, making sure that our riders are wearing masks, they have sanitizers, and thus playing a role in containment of novel coronavirus. So that was the scope of this project. So yeah, that's so like these are some very sample projects that were undertaken by me when I was at Shadowfax. And even to date, they have been taking up some really interesting problem statements. I guess one of them have been given to you for your hackathon too. Uh, so there's a lot of really exciting stuff going on in the industry and at Shadowfax in particular when it comes to the implementations and applications of data science. The entire truth of the story is that majority of the projects in data science never actually make it through to production, but that's not really the case at Shadowfax. Sole reason being that people over here give you time and the environment that is needed to get that project to the production stage. Um, uh, if we talk about some of the libraries that we frequently use in the industry, these are not much different from what you guys would be using for yourself. These range from using TensorFlow, Pandas, NumPy, Scikit-learn to some of the more ML implementation platforms like Prefect and MLflow, which help you properly organize and deploy your machine learning projects. So, yep. And if you would really want a tip for hackathon, I don't have much, but uh, the best I could say is uh, try to make like I came up with I just borrowed this quote from the internet where Albert Einstein said it's like make everything as simple as possible but not simpler. It essentially means that you really don't need that complex of a solution to get to a really nice elegant solution. Most of the times, the best solutions are one of the simpler ones. So if you just stick to the basics and work around the basics, think of it from a very first person point of view, go back to the first principles, then you should do just fine in the hackathon. And with that, I am open to any questions if you guys have.
That was a very enlightening session, Suyash. I'm sure people, realized, just how deep the applications of data science would be, in just a single industry. Uh, so we have a couple of questions in the chat. Of course, we'll get a bunch more questions, as we go along. So one
Mm-hmm.
of the questions is, regarding how college students are supposed to bridge the gap between the courses that they get over the internet and in their curriculum with the applications, like the applications you just demonstrated in the industry. So how they're supposed to
Mm-hmm.
bridge this gap, and there seems to be a major disconnect between the courses that are taught and the applications that are done. So how are college students expected to take this up?
Um, s- See, the way I would look forward to bridging this gap is first of all, you need to understand that even in an industry, when you're stuck, you really just go back to your first principles. You really go back to that very first lesson of loss function that you were taught, and you brainstorm on how to model that particular loss so that it would impact your ultimate outcome. So it's really like I think it's kind of a big misconception that there is a really huge gap. The gap is there, I'm not denying it, but that gap isn't that big. The problem where so the areas where actual problems seep in is in order to get quick results, college students don't tend to spend as much time as they should on the very basics, and they like tend to just uh, use some or the other libraries and rather than getting into the depths of things. And so once you start to get into depths of things, you would find that there isn't really much difference between what is going on in the industry and what is being taught in the academia. Now, if you just always use sklearn.fit or sklearn.train or model.fit, then you'll feel that there is a disconnect with what's going on in the industry. But if you do not do that, if you really go into the core basics of everything and try and understand that, and not just read, but implement. Be a part of different competitions, and then really spend time into understanding how you can improve your performance in those Kaggle competitions. Those are the kind of things you could do to really understand and bridge the gap between what is being taught and what is actually happening. Like you guys are taught linear regression, and then you move on to random forest, and then maybe onto like maybe deep neural nets at some point at some stage. So people use everything in the industry. It's not that they don't use those. Even linear regression is used a lot. Random forest is used a lot. So it's not that different. It's more into the details of things rather than just using 4 lines of code and getting a particular answer and getting to a particular level of accuracy. That's not what people look for in the industry. And then obviously there comes the scarcity of data. But there's still, like, if you look into the data repository of University of California, Irvine, um, then you'll find a whole bunch of data over there, which you can use for for very very different kind of applications. If you're like really interested, you just need to go there and get your hands dirty with the data.
Yeah, I hope that clears it up for you. We have another question from the audience about the
Mhm.
geo encoding algorithm that was displayed. How does it convert the address given in regional languages? Since most of the addresses in India are based on local
Yeah,
languages, so how does it convert that into geo coordinates?
yeah. See, so in order to make the algorithm understand the local language, what we basically transferred our knowledge from what is known in natural language from the domain of natural language processing. So what exactly? So if you come across natural language processing tasks, the way they try to understand the meaning of a word is like the way they try to figure out that okay, apple and orange are kind of similar, and king and queen are kind of similar is by doing something called uh, a pre-training, uh, and that happens like that happens in multiple ways. It's kind of similar into how you train your word embeddings. So that's how we first make our algorithm learn what the regional language is, and what the regional language and how the regional language connects. Like if you go to the northern part, you wouldn't find words uh like Halli or Chawl or Naka. Whereas if you go more towards the southern part of India, then you will tend to come towards like these words. But all at the end of the day, all of these mean some form of road, if not exactly road. Some form of road, some form of locality, some form of chawl, some form of gully is what these things are. So first your algorithm has to learn that okay, these things mean similar things. And then you try and then you train your algorithm so to predict coordinates so that it's able to understand those words and then be able to do it. Now I just cannot tell you the exact algorithm that I or the whole set of things that I did because everything is owned by the company and I'm not allowed to speak about it in a public domain. But yeah, that's kind of the meat of it. It's like transferring your knowledge where from the very basics into something that you want to apply right now.
I
So
hope that
Yeah,
clears that up for you, Avi. So over to you, Ash.
yeah. Hi, sir. So there was this one question that was I wanted to ask from you. So, how
mhm.
did you decide to move on to MS in abroad and continue your journey as a data science engineer or as a pursue your work in this field? So, how was your experience there?
Yeah, so I'm like essentially I went to do my PhD, but I had to come back with an MS because of my family circumstances. So that's the sole reason I came back after an MS. But I'm like, yeah, during my PhD, I was working in the domain of neuroscience, where I was trying to make computational models of how the brain works, like as to how memory formation happens. And if you look really deep into this entire domain of deep learning, then it has its genesis in the domain of neuroscience. They are trying to replicate how brain learns. That's where the whole motivation comes from. And so I got into this entire domain more and more, I started to learn extremely deeply about this whole domain of deep learning. And then when I was coming back, I was more or less like very sure that I wanted to pursue this particular field, mostly because I could see the great impact it can have on anything, literally anything, not just the logistics domain, but on the gaming community, on the operations community, on the medical community. This particular domain has almost infinite capacity. So and it gives you like you have math and then you have this opportunity to implement math to actually bring about changes in the world. So
Yeah.
without getting too much into the architecture, without getting too much into the so-called software engineering front of it. So
Yeah,
that's kind of really motivated me to like be a part of this particular domain.
yeah, even I did a bit of my homework and I found out that you were working with the brains of mice, and
Yeah.
that sounded quite interesting at first, Madhav. So yeah,
Mhm.
so yeah, over to you, Akash.
Yeah, that was really enlightening, so Yash. So, you are currently, working on a startup called Insane.ai, right?
Mhm.
And, so you had a lot of experience working on projects with Shadowfax. So, how do you, this even goes out to you, Anurag. So, how do you think the projects, people pursue at, one firm help their experiences later on in life? Because they might go into a sector that's completely different. One is logistics and another is more heavily related with AI. So how does the experience of one firm help people further in their career?
Um, I would say it helps you greatly. I'm like wherever you go, you always learn something. Like when I started off at Shadowfax, I didn't know anything about industry. And at the end of the day, it's the concepts remain the same. It's always the same thing. It's like, yes, 1 + 1 equals 2 and equals to 2, and that is what you are doing. If not with the structured or tabular data, then with the image data, then with the video data. If you're really clear on the first principles, then conceptually you're not that far behind. Now, when it comes to implementation, then yes, the manner in which you think about things, the manner in which you think about the business changes. But again, the core principles does stay the same. And I guess my experience at Shadowfax has helped me really greatly here at Insane, where I have it really helps you develop a very different insight about different domains, and and then it helps you use those insights into the current place or into the current company where you're working.
Right. So even with specialization in certain industries, it's possible. It's completely possible for people to apply the same knowledge in other domains without relearning the entire, uh, without going through the entire process again.
Um, yeah, I'm like, you don't have to be a part of an industry right from the very scratch, as far as I personally believe, but you should be very, very strong on the fundamentals. Like till the time you're very strong on the fundamentals, you are not going to have any problems, irrespective of what industry you're working in.
Fair enough. Yeah, that goes for pretty much every industry. Not just data science. On that tangent, how is the hiring process at, so if someone wants to work on these exciting projects that you just demonstrated, so what would be the process for people, to get into a firm like Shadowfax?
Um, Anurag, would you like to take this question?
Uh, okay. So I mean, uh, after you apply or after we get your resume somehow, we specifically for Shadowfax, we have an initial preliminary interview round where we just uh, basically just to weed out the people, right? Uh, because we don't want to waste anyone's time. If we are sure that uh, we're not going to go forward with this particular person, then after that we have a case study, something similar to the hackathon problem statement. Uh, I mean, we have different kinds of case studies. Some are more broadly stated. Some have looser answers. Some are very specific, right? Like this one, for example. And then based on the case study, so the case study it's a take-home problem, right? We allow you, we give you like 10 days or something to work on that. And then after that, we have a technical interview based on your response to the case study. And if you pass that, we have a cultural interview at the end to make sure that you fit in culturally. And yeah, that's pretty much it. Specifically for Shadowfax, because I mean, I'm not sure about Insane or any other company, but yeah, that's the process at Shadowfax. For data science, I mean, again, for SD and other tech teams, it's different.
Okay, that I feel like that clears up there in that section. If anyone in the audience is considering applying for a data science firm, I feel like that'll be the general pathway to securing a position there. So with that, we come towards the end of the session, and if there are any more questions from the audience, to any of us, to Suyash, to Anurag, or to the Consulting and Analytics Club itself, you may reach out to us on our social media handles that have been linked in the description. And once again, thanks a lot to Anurag and Suyash for taking their time out on this evening to tell us about many of the exciting things that we do at Shadowfax. And thanks to Shadowfax as well for the support with Cascade Cup 22. Thank you so much. Good evening, everyone, and thank you for attending.
Thank you.
Thank you.